let's see if we can, let's start by counting the number of ways there are of getting king high. Now, what makes card hands interesting and illustrative, why it's a good thing to look at is the strategies for figuring out how many ways there are of getting these different kinds of hands are different. The same strategy doesn't generally work for different hands. You've got to figure them out. So this illustrates different strategies for counting and illustrates that when you get a problem, you got to figure out how to solve the problem, not just look it up in the book, right? All right. So here, how many ways are there of getting, let's say, a king high hand for the sake of argument? What has to happen for our hand to be king high? Got to get a king, right? Okay. So how many ways are there of getting a king? 4. Okay. So we've got to get 4 ways to get it. There's 4 ways to get a king. Now, what else do we need to get? Okay, everything lower than a king. We need 4 more cards. Those cards have to be lower than a king. Let's call aces high for the sake of this. So we need 4 cards that are not kings or aces. Sorry? They can't be the same. I can't get 2 4s, for example, right? And they also can't be consecutive leading up to the king, or I'd have a straight, right? I can't have 9, 10, jack, queen, king, or that would be a straight. And they can't all be the same suit, or I'd have a flush. Okay, so we got to figure out a way of making decisions that produce a king high hand without producing a hand that's higher. Now, the strategy for this particular kind of hand is going to be, let's count things that count extra stuff we don't want and then subtract off the extra stuff. That's going to turn out to be the easiest strategy for this hand. This is one of the hardest. Well, there's some conceptual difficulties on the others. This is one of the hardest. All right, so we've got 4 choices for the king. And now we need to eliminate the kings and eliminate the aces and pick 4 of the remaining 11. There's 11 kinds of cards left. If we pick 4 distinct kinds of cards from the remaining 11, we've avoided getting a pair, or 3 of a kind, or 4 of a kind, right? Because we're asking for 4 distinct kinds out of the 11. That's eliminated getting multiples, yes? So if we take 4 times 11, choose 4, we've now specified which of the 4 kings we've got and which 4 of the remaining kinds of cards we get. But the problem is 11, choose 4 includes 9, 10, jack, queen, king. It includes 9, 10, jack, queen. And if we got 9, 10, jack, queen and have the king, we'd have a straight, not a king high. So this number, 11, choose 4, has counted some extra stuff we don't want. How much extra stuff has it counted? There's 13. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king is 13. We don't want to get aces and we don't want to get kings. Right? If we get an ace, we have an ace high instead of a king high. If we get a king, we have a pair of kings. So there's 11 different kinds left that we can pick from without blowing it and getting a better hand. Okay, we're talking about kinds of cards here. So it's okay to get ace, 2, 3, 4. It's okay to get 2, 3, 4, 5. It's okay to get ace, 5, 7, 9. It's just not okay to get 9, 10, jack, queen. There's only one of the 11 choose 4 possibilities that doesn't work for us because it gives us a straight. So we need to subtract 1. Okay, but we're not done because all we've specified here are what kinds of cards we got, not what suits we got. Okay. Why 1? Because I want all ways there are of picking 4 cards from 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, but not the one of those that corresponds to 9, 10, jack, queen. So it's all of them except that one, which would then give us a straight. Okay. All right. Regretting slightly doing this. Okay, so now we have one. Well, having done this way, let's do it this way. Instead of 4 kings, let's just say we're picking the faces of the cards first. So there's one thing. We're picking king. And now let's worry about the suits of all of the cards. Okay, so we now have 5 cards in our hand. We have a king. We have 4 cards that are chosen from 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, but not 9, 10, Jack, Queen. Okay, and now we need to assign suits to those 5 cards. How many ways are there of doing that? I get 4 choices for the king, 4 choices for the second card, 4 choices for the third, etc. 4 choices for each of all 5 cards. That's 4 to the 5th. Right? 4 times 4 times 4 times 4 times 4. But some of these don't work because some of those have all cards having the same suit, in which case I'd have a flush, which would be a king high. So how many of these 4 to the 5th ways of picking the suits correspond to flushes? 4, right? There's all 5 cards are hearts, all 5 cards are diamonds, all 5 cards are spades, or all 5 cards are clubs. There's 4 possibilities. Okay. Are we done? With this one? we multiply, right? We have one choice of kind of card for the king, essentially no choice. We got to get a king. Then we've got to pick the other 4 kinds of cards we have, but we need to pick them in such a way that we don't end up with a pair of kings or an ace. Okay, so this picks 4 distinct kinds of cards from the 11 remaining ones. This avoids getting a pair, 3 of a kind, something like that. Avoids getting an ace, avoids getting another king. But it accidentally included 9, 10, Jack, Queen. So we subtract that one off because that would have given us a straight. And then we now know which 5 kinds of cards we have. We need to figure out which suits we have for those 5 cards. There's 4 ways of assigning a suit to each of those 5 cards. That's 4 to the 5th. But that entire set, 4 to the 5th, includes the flushes. And we want to subtract off the flushes because we don't want to count a flush because a flush is a better hand. So there's 4 ways of assigning suits to the 5 cards that correspond to flushes. Namely, all 5 cards are spades, all 5 cards are diamonds, all 5 cards are hearts, or all 5 cards are clubs. That's 4. Okay? All right. So that's the number of king-high hands.